What will be key for you to remember tomorrow when you take the open quiz is what cancels out what. All right, so ln cancels out E, and is the reverse true? Yeah. Okay, E cancels out ln. Well, then what will log cancel out? 2. Yes. Log cancels out 10. 10 cancels out log. Will that work for anything? And the answer is yes. So if I put log base 7, what will log base 7 cancel out? 7. 7. Okay, why does that work that way? It's because in ln, what is understood and implied is hanging out at the bottom of that little ln. There's a little e right there. That's why it cancels out the big E. Okay, and then after the log right now, the common log, what's hanging out right there after that common log? 10. A little 10. That's why it cancels out the big 10. And so that is why the little 7 that's hanging out on the log right there would cancel out a big 7. And that works for anything. Log base 3 is going to cancel out a 3. Okay, so that is going to be important, but it also works the reverse. So 3 cancels out log base 3. The big 3 cancels out the little one. Okay, that will work for any of those numbers, whether it's E or 10 or any number that you want. That's going to be huge and important for you to remember. Those two, just like a square cancels out a square root and a square root cancels out a square. They each cancel each other. Okay. Knowing that will help you be able to solve exponential problems. So let's say we have 5, parentheses 3 to the x, and that equals 40. To solve means to get x by itself. To get x by itself means you have to do stuff to both sides to cancel things out. So, what do you want to get rid of first? What do you think? Say it again, Alex. The 5, okay? That 5 that's hanging out as the lead coefficient, we want to get rid of it first. How do we do that? What do we do to both sides? We're going to divide. No, not a log base 5. We can do it with just division. We just need division. Okay? That gives me parentheses 3 to the x equals 8. Okay, now what do we want to get rid of? The 3. Okay, what do we need to get rid of the 3, which is different than how we got rid of the 5? Okay, it's different because how is the 5 connected to the 3? Yeah, what's parentheses mean? Multiplication. Okay, 5 was connected to 3 with multiplication, so we had to break that with division. 3 is connected to x by a power, so the only way we can break that is with a log. So we need to use the log of little base 3 with the big 3 to the x. But if I do it on one side, I have to do it to the other. So log little base 3 of 8. Now I have some powers I can pull to the front. Okay, I can pull x to the front. And what about on the other side? What can I pull to the front? Something, I can pull something to the front. Not a 3, a 3, because why? 2 to the 3rd. So I can pull the 3 to the front because 8 is 2 to the 3rd. Now, tell me again, what does log base 3 cancel out? The big 3. So log base 3 cancels out the big 3. Does that happen on the other side? Does the log base 3 cancel out the 2? No. Did I get x by itself? Yes. So the answer is 3 log base 3 of 2. Or we need to back up a little bit? Where do I need to back up, Daniel? I think maybe right here.
Yeah, how did you get the 2?
Okay. Because I know my powers. And my powers are that 8 is 2 to the third.
Oh, okay.
And because 8 is 2 to the third, the 3 can move to the front, and now I have 3 log 2. That's where it comes from. Okay, let's try another one. You can stop when you have x by itself. All right, so solve. 3 parentheses 10 quantity x plus 2 equals 27. Okay, I'm trying to get x by itself. All right, James, give me a first step. Okay, divide both sides by 3. That gives me 10 to the x plus 2 equals 9. So I just got rid of the 3. Jacob, what do I want to get rid of next? Okay, so I need to actually need to get rid of the 10 first. Okay, but you do use a log. Okay, what log do I use that's going to cancel out 10? Common log, regular 10. So common log on both sides. Now I want to use my power rule. And my power rule says, what do I move to the front on the left? X plus 2. Leaving me with log 10. And my power rule says, what do I move to the front on the right? 2, because 9 is 3 squared. Okay? What happens with the log and the 10? What happens with the log and the 3? Nothing. They don't cancel out. Okay. Do I have x by itself?
No.
Not yet. How do I get x by itself? So x is 2, log base 3, subtract 2. Okay, let's try another one. $20, 1/2 x over 3 equals 5. Okay, we're solving that. We're trying to get x by itself. Okay, Daniel Besserell, what should I do first to both sides? Say that again? Divide by what? Yeah, I don't need, the 5 is fine. I'm trying to get rid of things that are by x. Okay, the 5 is not by x, so the 5 is okay, but I do want to divide, and I'm going to divide by 20. So that leaves me with parentheses 1/2 x over 3, and it leaves me with 1/4. All right, the next question. What do I want to get rid of, and how do I get rid of it? All right, what do I want to get rid of next? How do I get rid of a 1/2? I don't know what that means. I can't read, Austin.
Square root.
Not when 1/2 is just a number. When 1/2 is a power, it's a square root. Okay, you're right. I got to get rid of the 1/2. All right, so let's look back. I needed to get rid of the 10. How did I do it? I used a log. I needed to get rid of the 3. How did I do it? I used a log. I need to get rid of the 1/2. Todd thinks maybe he knows. I'll give him a chance, and then Ryan. Okay. Ryan? You know an easier way. I can't when it's got the x over 3 in it. I wish I could. The x over 3 as a power means I can't do that. That would be fantastic if I could, but I can't because of the power. All right, we want to use a log. We want to use a log on both sides, and I deliberately haven't filled in the little bit of the log yet. Okay?
Oh, yeah, it is. Oh.
Okay. The bottom part of a log can't be a fraction. Can't be a fraction, so it's not 1/2. And it can't be negative.
Oh, it can't, oh.
No. Can't be decimal.
Can it be?
It's got to be a whole number. Okay? Oh, what are we going to do with that? Okay. So let me give you a little bit of... Oh, Daniel, go ahead. I want to hear more about that. I want to hear more about that. What if I put a 2? All right. What if I put a 2? Okay. Because why would I put a 2? All right, well, here we go. This is why. Because that 1/2 does not mean radical. It means 2 to the -1. That's what that 1/2 means. It doesn't mean radical. It means radical if it's the power, but if it's a number, it means 2 to the -1. I still have the x over 3 here. And what does 1/4 mean? 2 to the -2. Gotta know your fractions. Okay? What does 1/9 mean? 3 to the -2. What does 1/25 mean? 5 to the -2. Okay, so now, what power can I pull in front on the left side? Or powers, plural. On the left side, what can I pull to the front? Both of them. Didn't I pull 2 things to the front last time? I pulled x plus 2 to the front last time. And what can I pull to the front here? For sure. Okay, so we're going to have -1, and we're going to have x over 3 in front of log base 2 of 2 now. And we're going to have -2 in front of log base 2 of 2. And the log base 2 of 2 on the left cancels out, and the log base 2 of 2 on the right cancels out, and I'm left with -1 parentheses x over 3 equals -2. And I just need to get my x alone now. So what shall I do to both sides next? Divide by -1. That will just give me x over 3 equals +2. And then what will I do to both sides next? Yeah, I can cross multiply and multiply by 3. That's going to give me x equals 6. Okay. We have a couple more to work on. So if you had solve 1/25 to the 2x equals 1/125. All right, what gets rid of the 1/25? Same answer to the last 3 questions we've done. What gets rid of that thing that's in parentheses? A log. But what log? Oh, now you're getting it. Log base 5. Now, why would you choose to use a 5? Because 1/25 is what? 5 to the -2. And if you use a 5 on the other side, why would you choose to do that? Because what's 1 over 125? 5 to the -3rd. Okay, gotta know your powers. That allows me to pull both of the powers to the front. So I'll have -2 and 2x pulled out in front of log base 5 of 5. And I'll have -3 pulled out in front of log base 5 of 5. Which means my log base 5s of 5 reduce out, leaving me with -2 times 2x equals -3. which is negative 4x equals negative 3. So x is negative 3 divided by negative 4, which reduces to 3/4. Are you getting that? Are you following it now? Have we seen it enough times? Repeat,
Yes.
repeat, repeat. Okay, let's try something new. I have 3 more. Each one is a little newer.
3 more. Alright, let's do
3 more examples. All right, folks. 5 minus 4e to the negative x equals 3. All right, Ashley, get me started. What can I do to both sides to work towards getting x by itself? Good job. She says subtract 5. All right, that's going to give me negative 4. E to the negative x is negative 2. All right, Hallie, next step. What will I do? What do I want to get rid of next?
You want to get rid of the negative 4.
And how do I do that?
Use a law.
Not to the negative 4.
Yeah.
Okay, what do I want to get? She's right. I want to get rid of the negative 4. How do I get rid of it? I just divide. Okay,
Oh, wait. I thought we couldn't do that.
Oh, wait. Oh, wait.
how is the negative 4 connected to the e? Multiplication. Okay, and so you just say, how is it connected? And just like, how is the 5 connected to the rest of the problem? All right, great. Now, you were on the right, so negative 2, we got 1/2. Okay, now, Hallie, what do we want to get rid of next?
The negative x.
What do we want to get rid of, though?
Oh,
E, and how do I get rid of
Yeah.
E?
You would use the natural law.
Okay, I want Lenny to get rid of e. So I'm going to have natural log to help me get rid of, but on the other side as well. Okay, now the property on the left side says to do what with the negative x? Bring it to the front. All right, so I'll have negative x out in the front of ln e. What property do I use on the other side?
Who knows?
You just took an open quiz on it today. Okay, we got to try and remember. Nice, Marcus. ln1 minus ln2. Okay, that is called the quotient because 1/2 is a quotient, and I can separate it. Okay. ln e. Gone? Okay, so negative x equals ln1 minus ln2. Divide by negative 1. Okay, now I'm going to rewind a minute. Marcus suggested using the subtraction property, which is great. Did anyone else think of any other property that we could have used to redo this same problem? Because there's another one. I'm going to... How else could we have done it? Because there's not always just one way. What else can I do with 1/2? It's the same thing we just did with 1/4 and 1/25 and 1/125th.
Half is 2 squared.
Half is not 2 squared. That would be 4.
2 to the negative. This sum.
2 to the negative 1. So then what could I do with the negative 1? Move it to the front and have negative 1 in front of ln2. And then what happens when I divide by my negative? I get positive ln2. And that would be the same equivalent answer, an even better answer than the other one. So different properties can be applied as long as you're applying them correctly. All right, 2 more, and then we'll have 1 more, and then we'll be done. Yeah, you can do it, Daniel. You can do it. All right. 3 parentheses 2.14 to the x equals 5. Okay, Daniel C. What do I want to get rid of first, and how do I get rid of it?
I'm gonna go get rid of that 3 first, dividing it on both sides.
Okay, so I'm going to divide 3 on both sides. So that's going to give me 2.14 to the x equals the fraction 5/3. All right, what do I want to get, Faith? What do I want to get rid of next? I don't need you to tell me how. I just want to know what do I want to get rid of next. Okay, 2.14. That's what I want to get rid of next because I'm trying to get x by itself. Okay, now this is a decimal number. Okay, and logs, like we would love for there to be a log base, and we would write 2.14 there, so it would cancel out. But what did I tell you earlier about log bases? They can't be decimals, they can't be negatives, they can't be fractions, they have to be whole numbers. There's only one log that has a decimal base. Which one is it? E, because E is a decimal. So we are going to use, not this one, we're going to use ln. So you're allowed to use an ln when there's an E and when there's a decimal. Now our properties say what to do with the x. Move it to the front. And our properties say what to do what with the 5/3. Break it up, right? How, Austin?
It would be ln plus or 5 minus ln 3.
Okay. And then we just have to get x alone by dividing. And the answer looks awkward, but it's still okay. So ln 5 minus ln 3 over ln 2.14. So don't just use ln for Lenny. Use ln when you have an awkward decimal also. Okay, last one. It's going to look scarier than it is. Okay, trust me. 250 divided by 1 plus 20 e to the 0.4x equals 100. Yeah, it looks terrible, doesn't it? That's magic. Okay, that looks awful. Solve for x. Blah, it looks terrible. Okay, until I do one little thing and it's not going to look bad anymore. What? Under 1. Okay, as soon as I do that, you're like, oh, magic. What can I do? I can cross multiply. So when I cross multiply, the 250 goes to what? Okay, so that's going to give me 250. Where does the 100 go? It goes both. Oops, it's like distributing. You got to do it to the 1 and the 20. You got to, you got to do it to both. So 100 times 1, that's easy. And 100 times 20 is also easy. And you have e to the 0.4x. So it's really not nearly as bad as it originally looked. Okay, Perry, what do I do to both sides next? Subtract 100. That gives me a 150 equals 2,000 e to the 0.4x. Okay, Daniel Bradford, what do I do next? Divide by 2,000. So 150 divided by the number 2,000 gets rid of that, and I have e to the 0.4x. 150 and 2,000 is reducible to 3 over 40. Okay, Alex, what do I want to get rid of next? So I'm trying to get x by itself. Well, look at, you've got two options, okay? What's on the side of x? You've got an e or an 0.4. Which one do you want to get rid of so you can get x by itself? How do you get rid of E? Say it again. Okay, I'm going to use ln. And so I'm going to get rid of E by using ln. So ln goes around 3/40, and ln goes around e to the 0.4x. And my properties say that ln 3/40 is ln 3 minus ln 40. My other properties say that the 0.4 can move to the front along with the x, and I'm left with ln, which cancels out. So I'm left with 0.4x and ln 3 minus ln 40. Now 3 and 40 aren't power numbers, neither of them are, so I can't break them up anymore. But I just need to get x alone. So how do I do that? Divide. And so x is ln 3 minus ln 40 divided by 0.4. Okay, that finishes it